Start with a single node. 3 inputs arrive. Each one is just a number. The node does one thing. It multiplies each input by weight and adds everything together. That's the weighted sum. Multiply, then add. That's all a node ever does. Now add more nodes. Every node receives the exact same input, but each node has different weights. So each node produces a different output. Same data in, different answers out. So what are weights? They are questions. Each node asks something different about the same data. For example, should these values be closer together or farther apart? Should this pattern be emphasized or ignored? Should something be stretched or compressed? Weights define the question. Training finds better questions. Now watch carefully. We shuffle the nodes. The values don't change, only their positions change. Now look at the next layer. This layer has its own weights. It does not know the nodes were shuffled. Now run the computation. The outputs are identical. Nothing changed. Because the computation depends on values, not positions. Order does not exist here. The network cannot tell what came first. So if order matters, we must add it. We add a pattern, a gradient, a wave. But this wave is not meaning. It is a clue, like a hint on a puzzle. It doesn't tell you where the pieces go, but it helps you figure it out. The network does not understand this at first. It must learn how to use it. Through training, it learns that nearby values in this wave correspond to nearby positions, and that differences in the wave encode distance. We don't tell it what the wave means. It learns the meaning itself. The structure is given. The interpretation is learned. What does a layer do? Here is the data. Blue and yellow are mixed. There is no simple way to separate them. In this space, categorization is hard. Now the layer acts. It rotates the space. It stretches it. It compresses it. Now watch. What was mixed is now separable. Not because the data changed, but because the space changed. The layer didn't label anything. It didn't recognize blue or yellow. It transformed the geometry so a simple question can answer it. Can these points be separated? In the right space, the answer becomes simple. Now remove a node. Nothing obvious disappears. No single fact is lost. But something is gone. A question. One way of understanding the data no longer exists. The network doesn't store information in pieces. It stores perspectives. Remove a node, and you lose a way of seeing the data. Every set of weights is a point in a vast space. Training moves through this space, step by step. Each step adjusts the questions. The loss decreases. The questions improve. Training is not memorizing facts. It is discovering how to ask. Now consider a sequence. Each token is a point in space. Each carries meaning. Now we average them, a single point remains. This is not just averaging, it is a geometric center. A stable encoding of the whole. Because each token already contained the whole in transformed form. This is the engram. Token is not a number. It is a position. Meaning is location. Relationships define meaning. Everything we've seen. Weighted sums, transformations, pooling, attention. They are the same operation. Repeated. Multiply, then add. At the beginning, we started with multiplication and addition. A simple operation. But inside it, the network learns questions. It learns how to reshape space, how to use clues, how to turn numbers into understanding.